So on this one, we're approaching C from the right, and in this case, it's 8. And so just as a reminder, 8 plus means 8.001, whereas 8 minus would mean 7.999. So to the right and to the left. Okay, I guess I'll label that. From the right and from the left. Okay, so on this one, the first step would always be try to plug in the number if at all possible. I think in this case it's going to work. So let's just put in 8 times 8 over 8 plus 1, 3 times 8 plus 8 over 8 squared plus 8. That is a ton of parentheses, and even if I'm typing it exactly the way I'm doing it, I'd need that. If you'd rather just type in the function and then look in the table, you can do that. Or type the function and use the table. Or if you want to take steps. So I'm going to take steps so I can do some of this mentally because it's quicker. 8 times 8 is 64. 8 plus 1 is 9. And then this is 24 plus 8, which is 32. And this is 64 plus 8. $72. And then just multiply your numerators. Well, you could do whatever. You could multiply your numerators like that, divide by your denominators. Oops. And that gives you 256 over 81, which is what we wanted. Or if you want to divide them separate, you could have said parentheses 64 over 9 times 32 over 72. There's no reason to simplify your fraction until the final step. Like here I could have divided by 2 or 4 even, but it's not even worth it until the very end to reduce it. Okay, so that's how you do that one. Now on this one, I just do a spot check. Okay, if this is 0, 0's in the denominator, it's not going to work the normal way. And so what we have to do, I believe in this case, is try 0.001 or multiply by the conjugate. I try the shortcut first. So we're going to try square root of 0.001 squared plus 4 times 0.001 plus 11 minus the square root of 11 over 0.001. Let's see where that gets us. It is a trial and error type thing. 0.001 squared. Now, it's also not an exact number of zeros. You really could have an infinite number. I'm just trying to keep it reasonable and easy. 4 times 0.001 plus 11. Whoops, the plus 11 should go under the square root sign. Oh, shoot. It's too bad there's not an undo. 0.001 squared plus 4 times 0.001 plus 11 minus square root of 11 and then divide by 0.001. Okay, that doesn't really help us too much. I know it's approximately 0.603, but that's not going to work out the way that we had hoped. Okay, so when we multiply by the conjugate, the first step would be square root of h squared plus 4h plus 11 minus square root of 11 over h. Now, when we multiply by the conjugate, we would put the same thing on top and bottom, but since this one has a minus sign, then we would want to use a plus. So we're going to have the square root h squared plus 4h plus 11. So we keep all those signs the same, but then put plus square root of 11 over the exact same thing. The reason why you're allowed to do this algebraically is because you can always multiply by 1 without changing the value. Now, it's a very complicated form of 1, but that's all that really is. But what that does is it lets us go this times this, so it's the same thing without the square root, which is actually very useful. And since it is plus and minus of the same thing, you're not going to have a middle term, because square root of 11 times that minus square root of 11 times that cancels. So then we're just going to have minus 11, which also is very helpful because that just cancels out. And then I'm going to keep this as h times the square root h squared plus 4h plus 11 plus square root of 11. Now, if we let, excuse me, when we factor out the h from the numerator, that'd be h plus 4. And then we're just going to leave our denominator the way it was. H squared plus 4h plus 11, then plus square root of 11. The reason to do that step is so that your h's cancel. So then, excuse me, now we say h approaches 0 from the right, and so, dang, 0 plus 4 is 4, and then the square root of 0 squared plus 4 times 0 plus 11 plus square root of 11. That would simplify to 4 over square root of 11 plus square root of 11. And you could probably see from here it's going to work. We get 4 over 2 square root of 11, which is then 2 over square root of 11. So that's how you do that one. Okay, on this one, let's try just plugging in the -7, see if it works. Well, you get a divide by 0, so that's not going to work. So it says find the limit from both the right and the left. Let's try this one just with your numbers. We're doing -7 from the left and from the right. From the left it'd be -7.001, and from the right that would be -6.999. So those are the numbers I'm going to try plugging in and see how it works. -6.999 times parentheses -6.999 plus 7 divide by -6.999 plus 7. Okay, oh, I forgot one quick step. This one we were supposed to do plus 13. Let's do our parentheses. Okay, so that plus 13 times that over that. So that gives us 6.001, and so we can just make that 6, and then we're going to do the same thing for the denominator. Basically change all the 9 nines to 7.001. But that does need to be a negative 7.001. Okay, that gives us 5.999. And so that's going to be, wait. Okay, so right there, this step, I need the absolute value, because it's actually going to turn into the, it's going to turn into negative, but we want it to be positive. So we're basically going to end up flipping the sign. Okay, negative 7.001 plus 7. Okay, so here we get negative 5.999. And so then we put negative 6. So remember to use the absolute value symbol. Now, one other quick way would be if we did graphing it. X plus 13 times the absolute value x plus 7 divided by parentheses x plus 7. And we're interested in what's happening at negative 7. So I'm going to do menu 4A. And I guess you can trace, or you could just look in your table. Okay, so it has negative 7.001 for this one, and when I do to the right, it's negative 6.9. So the other way, like I said, was or graph and use trace. And on one end, I got negative 6.9 comma 6.1. And on the other end, I got negative 7.2 comma negative 5.8. And so what we're looking for in that case is the y values. And so we call that 6 and we call that negative 6. So there's two approaches. Now I have to cut this short because I have to go to cafeteria duty. I hope you'll have a good day.